Okay, here's the big day, getting to talk about something called the unit circle, which will be, for anyone in precal and calculus, just, man, it's like your new multiplication chart. You have to know this circle, and I know it looks a bit overwhelming, but that's what this video is about, is to go over what we're looking at, why it looks like it does, and then how to use it. So, first things first, why is it called the unit circle? Pretty much, the idea is the unit circle is centered at the origin and has a radius of 1, okay? Centered at origin with radius of 1 unit. Now, that's why it's the unit circle. The radius is only 1 unit. Now, I don't know if we're talking, inches or miles or whatever. I pretty much just think of it as I'm on the coordinate plane, like the x and y axis. And so because of that, when I look, if this is the origin, when I go to the edge of the circle here, if the radius is 1, then I'm at the point 1, 0. So that's why you see coordinates listed on the outside, is because the radius is 1. So the main 4 are pretty easy. I mean, if I go to the right, it's 1, 0, but if I go to the left, it's negative 1, 0. If I go up, it's 0, 1, and if I go down, it's 0, negative 1. That's just, that's just working around a coordinate plane. Now, what's cool about this is that you've got everything labeled in one place. Now, notice there's little pieces of pie here, right? The idea is that we go around and every 30 degrees a different angle is drawn, okay? So remember, you start in the east with 0 degrees. So you start measuring in the east and you go counterclockwise. And when you move counterclockwise, you count off every 30. So 30, 60, 90, 120, 150, 180. I'm just adding 30 each time, and that's what all of those angles are. And then after you go around and check out all the 30s, you go around and add all the 45s. So 0, 45, 90, 135, 180, 225, and you count around that way. Now, inside of that, like if we look right here, this would be the radian that goes with 30 degrees. And if you don't remember that, we learned how to convert degrees to radians in another video, and to convert into radians, we had to multiply by pi over 180. And when you do that, you get 30 pi over 180, and you reduce. So this becomes pi over 6. So that's why those are sitting next to each other, is someone has gone around and converted all of these important degrees to radians, okay? Now, why did they choose these degrees? I mean, why not do every 10 degrees or every 25 degrees? I mean, why choose these? Well, the reason that these were chosen is because you may remember from geometry a long time ago, there's actually a special relationship between triangles that are 30, 60, 90 and triangles that are 45, 45, 90. And I'm going to kind of erase what I did here just to give you a better idea, and trust me, your teacher will show you this as well next year, but just so you know where I'm coming from here, if I were to think of this as, the bottom of a triangle, where my angle begins, and this as my hypotenuse, then I could come out to this point on the circle, and I could drop a line straight down that would form a right triangle, and it would be this would be 30, so it would be a 30, 60, 90 triangle. And whenever that happens, you might remember from back in the day, and if you don't, it's not a huge deal, but on a 30, 60, 90, this side was x, this side is x root 3, and this side is 2x. These were just the special relationships around the outside of the triangle, and they're also on the SAT, so they're kind of good to know. But anyway, we know that if this is the unit circle, we know that the hypotenuse is the radius. And so the hypotenuse is 1 unit long. And if that's 1 unit long, when I look up here at this picture, I know that the 2x is now a 1. Those are equal because we're doing the unit circle. And just by solving for x right here, you can see what's going to happen. If I divide both sides by 2, I get that x is 1/2. So notice the vertical right here is 1/2. Now look at the point over here, guys. The y value on this point, also 1/2. That makes sense now, I hope. This one, you're supposed to take your x value of 1/2 and multiply by the square root of 3. Now when you do that, what happens? It's square root of 3 over 2. And there is your x value. This should make perfect sense, because if you're trying to get to any point on the circle, you have to go over x amount and up an amount of y, right? That's your x, that's your y, and that's how you get to that location. So they're just the legs of this right triangle, and we use old school geometry to figure that out. So these angles were chosen because there's only 2 special right triangles out there. There's the 30, 60, 90, and there's the 45, 45, 90. There's no such thing as a 10, 70, 90 triangle like that. There's no special relationship on a triangle like that. Now let's look at the 45, 45, 90, okay? This is the last one we'll do just so you can see it. It's going to be the same idea. We're going to go up to the circle. We're going to drop down to make a right angle right there. And we're looking for our x, and we're looking for our y. Now I know this already tells you what they're going to be. I just want to show you why they are what they are. Okay, so if you remember from geometry, these were matching. This was x, so the legs were x, and the hypotenuse you just have to multiply by the square root of 2. So this is the old rule, and same thing that we did up here. The hypotenuse here, since it's the radius, it's still a 1, which means this is a 1. So if I want to solve for x, how do I get that square root of 2 off of x? Well, I divide it off. So this is going to become, x is going to become 1 over the square root of 2. Now, some people might write it as 1 over the square root of 2, but I think what's happened here is a lot of people, even in geometry, algebra, precal, they don't like a radical on the bottom. They say that it's poor form. And so if you remember, you're supposed to rationalize something like this. So if there's a square root of anything on the bottom, the trick is to multiply it by whatever it is over itself. And this is called rationalizing. So this is kind of an old lesson if you forgot how to do that. Rationalizing the denominator. And when you do that, you get the square root of 2 over the square root of 4, which is 2. And that's why you see those 2 numbers up there. So now that you know what we're looking at, I mean, this is just degrees and their radians, and now their coordinates that lie on the circle, let's talk about the fact that, oh my gosh, I have to memorize this, and that seems a little ridiculous. And so we are, I'm going to use this section right here to write down a few notes. If you already wrote down those notes up there, that's perfectly fine. I would just put a few things here where we are looking at degrees, radians, and coordinates for all special angles around the circle. That's what you see above, okay? And what I want to do right here is to help with some memory tricks. And they're not, I don't know if they're really tricks or not, it's just observations. The first thing that I'm going to write, and then we'll go back up here and look at, is to remember that a circle has all kinds of symmetry. Because that's going to be like really important. A circle has all kinds of symmetry, meaning that if I were to take my circle, I'm going to erase some of the stuff that I've done here, and if you have it written on yours, that's fine. Don't worry about it. You don't have to erase it. Okay. If I fold my circle on the x-axis, then everything from the top and the bottom are going to match up, okay? Because everything is equidistant from the origin. So that's my first memory trick, is to just fold the circle and look at what matches. The reason for that is because let's just focus on maybe something like this. If we were to take this angle right here, when I fold the circle across the x-axis, that little point right there would reflect and be right here, right? This little line would now be down here. Look at these coordinates, okay? They are the same, with what exception? Well, the only exception is that this one has a negative and this one has both positives. But that is not something that you need to memorize. That's just called, hey, I'm in the fourth quadrant, and in the fourth quadrant, my y value is negative. So if you just memorize these two numbers, you're going to know these two numbers. You just have to decide if it's negative or positive. The same thing goes with folding across the y-axis, right? If I was to take this circle and fold it across the y-axis, now this point right here would match up with this point right here. So notice the same thing. This and this are matchers, right? They match each other, except in quadrant 2, the x has to be negative. That's just the laws of moving around a coordinate plane. So there's your step number 1, is check out the symmetry, because if you know the coordinates from quadrant 1, you know the coordinates of the entire circle. So that's what I train my kiddos to do. Memorize first quadrant and use the symmetry to figure out the other quadrants, okay? Now, that same thing that we just did is actually awesome, because it's going to work for the radians as well. You are going to love this. It's going to work for the radians as well. And here's what I mean by that. Let's go back to the original red one that we drew here. Let's look at the radian here. Okay, the radian here is pi over 3. Now let's look at the one that it matched to down here. And let's look at the one that it matched to over in that quadrant. Okay, look at those. Now, all of them have what in common? Hopefully you're noticing the denominator. They all have the same denominator. Now, if you're wondering about this one over here and you're like, wait, I see another one that's over 3 in this quadrant. Why didn't you circle that? Well, I could circle that because remember what we were saying about symmetry? I could fold the circle this way, I could fold the circle this way, and then that definitely is going to match this one and this one, no matter which way you fold the circle. So all 4 of these have the same denominator. Now look in the middle of each quadrant. This one is over 4. This one is over 4. Look at the middle of each one, over 4. So this is kind of cool, y'all. I mean, if you understand symmetry and folding your circle each way, then you're going to know whose radian matches what, okay? What radian matches what. So that's another reason why you can just memorize the first quadrant and then just remember, or remember to do symmetry, okay? And you'll know, so all of these are over 6. Through the middle, they're all over 4. They match that one. And then anywhere you fold this one, they're all over 3. So you're just memorizing these 3, and then we can look around the circle and do the rest. Now, the only other memory trick I have for this is I have a memory trick for all of my numerators, and I'm just going to point at it here, and then we're going to write it down below. So don't write anything down right now. Just listen and pay attention, and this might help, and then we'll write it down below. Okay, here's how I memorize this. Now, I would already have memorized these denominators, and I remember that in the first quadrant, the numerator is just a 1 pi. Like, the numerator is just a normal, I think of it as a 1. I don't really even think of the pi. I mean, I know there's a pi there, but anyways, nothing special here. They're all the same, okay? Now, in this quadrant, in the second quadrant, I notice that the numerator is 1 less than the denominator, okay? So I usually write myself a little note here, denominator minus 1. So my numerator is denominator minus 1, and of course there's always a pi on it, so if you want to stick a pi back there, you can. And now in this quadrant, what do you notice? 7 over 6, 5 over 4, 4 over 3. Oh, now it's the denominator plus 1, and then there's a pi behind it. Okay, so those are going to be your numerators. And then over here, this one's kind of tricky, but it's not too bad. I look for a pattern. Since I was using denominators here for my pattern, I look for a pattern here as well. And for this pattern, I do the denominator doubled minus 1. Double minus 1. Double minus 1. And so that also works. So 2d minus 1 pi. Now, if you hadn't written this around here because it's so junked up with other notes, I get it. So I'm going to rewrite that down here. So here was my other little memory trick. Okay, so for all the numerators, so this is my numerator key, 1 pi. This one's denominator minus 1, denominator plus 1, 2d minus 1. And that's how I remember. So when I lay it out, I will lay out all of the denominators that I memorized, and once I lay out those 3 that I memorized, then I can do the symmetry to jump into the other quadrants. Then I can figure out my new numerator. So if you know this well enough, you can memorize that whole circle above, you know, without really memorizing it. You can just figure it out in your head real quick if you know these rules good enough. Okay? All right, so now some application, and I do apologize because everything we just did was just for your own benefit and the sake of knowing it. There were no math problems to go with that, okay? Now the math problems come in using the circle to find trig values. Okay, so the first thing I'm going to do is a trig value we've been doing already. So I'm going to rewrite what we know about the sine being the opposite over the hypotenuse, cosine, this is all our SOHCAHTOA stuff, right? Adjacent over hypotenuse, tangent, opposite over adjacent. Now, we also know the reciprocals of these 3. So the reciprocal of sine is actually cosecant, and that's where we flip that. The secant is where we flip cosine. Hypotenuse over adjacent, and then cotangent is adjacent over the opposite. Okay, cool. So we're taking all of these, and the reason why is because I want to show you how we're going to develop even simpler formulas for these 6 things based on the unit circle, okay? So remember how earlier when it was inside the circle and it was like, let's say it was like 45 degrees, okay? How I told you that to get that point right there, you just had to drop down and draw a right triangle, and then we could figure it out that way. Okay. Well, what's cool about this is when you've turned this into a right triangle, not only can you use your special right triangle rules, but we can also write the relationship of this is our x distance, this is our y distance, and this is our radius, but those also mean something else. Those mean these words as well. So we could label, if this is our angle, we would naturally label this one adjacent, this one opposite, and this one the hypotenuse. So it's pulling together the 2 worlds of labeling with words how things relate to the angle, but then also when you're on a coordinate plane and you're looking for that point, these are also x, y, and r for radius. Okay? And so based on that, I'm just going to turn these words into x's, y's, and r's. Okay? So the sine of theta is, instead of opposite over hypotenuse, it's going to be y over r. The adjacent over hypotenuse will be x over r. Opposite over adjacent, y over x. And then I'm going to flip all 3 of these for these. Okay? So r over y, r over x, x over y. Cool. So for some of you, these words work out great. For some of you, this one might now be your new favorite, because if you're on a coordinate plane, you can just do this instead. The other cool thing is that we are on the unit circle, right? So what is the r? Well, if it's the unit circle, r equals 1. So this actually simplifies these even more and turns it into, if you know you're on the unit circle, okay, now this has to be true, just kind of make a note. If you're on the unit circle and your r equals 1, then you could also do, this is just the y, because it would be y over 1, right? R is 1. R is 1 here, so this is just x. This would still be x over y, 1 over y, 1 over x, and then x over y. So you can simplify the r's down to that, and this makes it super stinking cool, like so cool, it's crazy. Here's what I would like for you to do, okay? Okay, we're going to do tangent. So here's, actually we won't do tangent first. Let's do sine first. Okay, so let's pretend that I was asking you to find the sine of 90 degrees. Okay, and I said don't use a calculator, and that's where it stumps people. You're like, wait, what? Don't use a calculator? Okay, here's what you're supposed to understand. Sine, if we think about the unit circle, sine is just y. Okay, so what this is asking is, go to 90 degrees, find the y value at 90 degrees, and that would be your answer. So 90 degrees on our unit circle, if you look up above, or just if you know it, 90 degrees is right here. And the point on the circle, if you're at the origin and you go up 1 unit, this is the point 0, 1. So what is the y value of this point? It's a 1, so I put a 1 there. Now, if you had picked up a calculator right now, in fact, pick up a calculator right now and put it in degree mode and type in the sine of 90, and it will tell you 1. So this blows people's minds because we've always used the calculator for sine, cosine, and tangent. But what I'm here to tell you is if you're ever doing an angle that's on the unit circle, one of these ones that we've listed above, if it's ever one of these angles up here, then all you have to do is put down the calculator and look up the formula that it's equal to, okay? Plug in the numbers and solve, okay? So here's another example. What if I asked, let me jump into tangent now. What if it said the tangent of 30 degrees, okay? So tangent of 30 degrees. Well, the first thing I do is think, well, what is tangent? Now over here, tangent is just y over x. So I need the y over the x at 30 degrees. So go look above, or on your other page, go look real quick. What is the y at 30? What is the x at 30? Well, the y at 30 degrees is 1/2, and the x at 30 is the square root of 3 over 2. So I'm just going to come back here, and in the place of y and x, in place of this fraction, I plug in those two numbers, and now I just math it out. Now I know this is not fun math, but this is all you have to do. It's just 1/2 divided by that, which is the same thing as 1/2 times the reciprocal of the bottom. Cancel, cancel. So you get 1 over the square root of 3. Now, I'm okay with students leaving it like that sometimes, but for a lot of the times and on things that you'll see, this is not cool. You want to rationalize this, root 3 over root 3, and then you want to multiply top and bottom. So I'm just rationalizing 1 over the square root of 3, and I'm getting the square root of 3 over 3. So this is the answer that you would see most often. But that's all it is, guys. That is how it works. And this could either be a degree, just a little note, or this could be a radian. So this is the same thing as if you saw sine of pi over 2, you would do this the same exact way. Okay, so it could be a degree or it could be a radian. Just pay attention and see where that is on the circle. Alright, cool. I know this is already a long video, but I'm just going to do one more down here as an example to get you started on your homework, okay? Solving trig equations using the circle. This is the same thing as above, but there is a little bit, like another step required before you can actually solve. So this would be like, instead of me just flat out asking, you know, sine of 30, sine of 45, cosine of whatever. Instead of me just saying that, you have to sort of solve for that. So An example might be like 2 cosine of x minus 1 equals 0. Okay, if you see something like this, don't freak out. The goal needs to be to isolate the trig function. Okay, so do whatever algebra you know to isolate that. So the first thing would be like maybe add 1 to both sides, right? After that, if you're trying to isolate that, you need to get rid of the 2, so you probably divide it off, right? And now what we're looking at is the cosine of x is equal to 1/2. Okay, so this is weird because there is not an angle written right here. Instead, it's giving me an answer, and we are supposed to find the angle. So it's the same thing from above, it's just backwards. You're going to be finding the angle now instead. So same thing though, what does cosine mean when you look at those little formulas? Well, cosine means the x value. So what this question is actually asking is find the angle whose x value is 1/2. And that's all that it's doing, guys. Find the angle that has an x value, because that's the word cosine, that's why it's an x value, is 1/2. And so you look around your circle, you could go up to your, you don't have it memorized yet, so go up to your circle, look all the way around, and the x values happen at 60 degrees. And they also happen below 60 degrees, so I think that that would be 300 degrees, okay? Or you could also answer as that would be pi over 6, and no, it's not, I'm sorry, it's pi over 3 and 5 pi over 3. So answer in either degrees or radians, but that's how a problem like that works. So do the best you can. This is a lot of information. Most of it had to do with memory tricks though, but hopefully it's enough to get you started, and we can talk about it in tutorials.